Hello and welcome to my presentation. I'm Patrick from the University of Vienna, and during the next approximately 10 minutes I would like to give you a short overview of our research topic, visualizing metric trends for software portfolio quality management. But before we dive deeper into this topic, we first have to clarify the term software portfolio quality management a bit. If we speak of this topic in the context of our research, we understand it as any decision-making activity that ensures and supports a common quality standard and process across multiple related software artifacts. But what does related software artifacts actually mean here? For us, the nature of the relation itself is not that important and is already expressed if all artifacts are part of the same quality management process. Whether they are totally different applications or only variations or branches of a single application does not matter for our definition. But what is it that makes software portfolio quality management actually so challenging? One aspect is the large amount of data that has to be monitored and tracked during the quality process. Portfolios can often consist of several dozens or even hundreds of individual projects. So there is much more data to track, especially if the quality metrics are collected over a longer period of time. Visualizing this data can often result in an information overload if no appropriate filtering mechanisms are applied. Another drawback is also that most available tools like SonarQube or Codicy, for example, might work well on the level of single projects and repositories, but often provide only rudimentary support for quality management on portfolio level. And the last point, which is very interesting, while there are some studies about the information needs of quality managers for single project management, there does not exist much research for portfolio quality management. But here it would especially be interesting to see whether and how these needs differ. And these aspects lead us already to our research question, which is, if we would try to develop a novel expert visualization system specific to software portfolio quality management, how would such a system have to be designed? Which features should it support? And how would the system be accepted by quality experts? To answer this question, we applied the following 3 steps. First, we collected relevant information needs that quality experts have when working with software portfolios. We did this by extracting information from the few existing studies, and we also enriched our findings by doing qualitative interviews with selected software experts. Based on these information needs, we defined a requirement catalog, which we used as a base for implementing a prototype. The prototype consists of a data mining component to extract relevant quality data from underlying source code repositories, and an interactive visual component, which experts could use to access and query the collected data. In the final step, we created some real-world-like quality scenarios and asked some experts to solve these scenarios by using our prototype. Based on our interviews and our observations, we evaluated the effectiveness of our prototype. Regarding the information needs, we were able to identify some important and recurring elements. One finding was that each stakeholder might need a different view on the data, and therefore different detail levels are required. But it should still be possible to navigate between these different areas. Also, historical trend data was rated as very important, so that quality managers would be able to see in which direction the portfolio and its projects are moving. Another important aspect mentioned by our interviewees was the possibility to define quality goals, both on portfolio level but also on the level of an individual project. Especially the possibility to get notified if the quality rules are violated was rated as very important. And finally, we also have the need for combining different metrics into a single view and comparing these metrics between various projects. Okay, and now I would like to give a very short demonstration of our visual prototype. Start the application and we can see the front end running here in a common web browser. The user has an overview of all available projects and all matrix. He can either choose a single matrix per project or could also decide to combine various matrices into a single diagram. Despite that, he can choose from various aggregate functions like sum, average or median. Now let's have a look at the next step. Let's assume I want to define a custom quality goal for the lack of cohesion metric. I can do this by clicking here and defining a rule that says our lack of cohesion should not be higher than 65. If I save this rule, I can immediately see that there are two projects violating this rule. I can even activate this threshold for seeing a better result here. But I can also see that the log4net project, for example, is going definitely in the wrong direction as the outcome value increases here, but the Maven project is the one where the rule is going better, becoming better. What I could also do, if I like, I can override this specific metric rule for every individual project. Now move to the snapshot view. Here in the snapshot view, users have the possibility to choose from several projects and compare specific commits of these projects over time. So for example, what I can do here is I see the distribution of the given metric for the specific commits here and here. If I now move the slider, I can see how this metric develops over time for each of the projects. And despite the distribution, I also have the possibility to see a list of artifacts and can even choose the artifact level, for example, file, class, or method based. And despite the artifacts, I also have a view that shows me the polar chart consisting of 3 or more metrics and shows the relation of these metrics for the given commits. This can be useful, for example, if someone wants to investigate specific patterns that arise if you compare one metric to another or similar use cases. For the final evaluation, we asked a group of 6 experts to solve a set of 7 common quality scenarios by using our prototype. To evaluate the performance of our tool, we used different criteria. First, the experts had to roughly estimate how long they would take to solve the task with one of their familiar tools, like SonarQube, for example. And then, during their task execution, we recorded the time they needed and compared it with their estimates. We furthermore did qualitative interviews with the experts and asked them about their impressions during the test and concluded the survey with an additional multiple choice questionnaire. If we look now on the results, we see some interesting insights. The first interesting aspect is that most of our scenarios were rated as relevant or very relevant. We can therefore assume that our scenarios are not too artificial, but represent some real-world challenges. Furthermore, if we compare the estimated efforts with the recorded completion time, we see that some tasks were estimated to take quite long, sometimes even more than 30 minutes when done with conventional tools. But the real execution time with our prototype was almost always shorter, especially for tasks which were guessed to be quite hard to solve. So, to sum up the results, we can therefore say that our expert system provides a novel approach to software portfolio quality management that is not yet covered by existing tools. And the positive feedback we received during the evaluation and the qualitative interviews also tells us that our tool really addressed some of the information needs we identified. And the tool was also well accepted by our audience. But it is also clear that our test audience is a way too small to be representative. So to have more reliable results, we would need a larger and also more inhomogeneous selection of quality and software experts for further studies. And here we are already at the end of my presentation. I would like to thank all of you for your attendance. And if you might have any further questions, please feel free to ask. Thank you.